Medical researchers interested in exploring this new medicine on blood pressure. 500 males with high blood pressure randomly selected and given a new drug. After 2 weeks, their blood pressure is measured and the average arterial pressure is calculated. We're looking for the population of interest, the parameter, and the statistic. The population is going to be, well, notice who she's taken. She's actually taken 500 males with high blood pressure. So that means we want to apply this to all males with high blood pressure. That is the hopes of this. The parameter of this is she's going to calculate, what she's calculating here is the average arterial pressure. So she wants, another word for average is she wants the mean arterial pressure for all males with high blood pressure. And then finally, the statistic for this one is going to be, it will be the sample mean arterial pressure of the 500 men in the sample. A study is conducted to determine whether or not the dangerous activity of texting while driving is a common practice. 1,500 16 to 24-year-olds are randomly selected and asked whether or not they text while driving. Of the 1,500 drivers, 12% indicate they text while driving. The population here is, well, since they're polling 16 to 24-year-olds, it's all 16 to 24-year-olds. The parameter is going to be the proportion of all 16 to 24-year-olds who text while driving. And the statistic is, well, it's the sample proportion. And if you look at that, our sample proportion is, it was the 12% who, yes, they indicate they text while driving. So our sample proportion is 0.12. And I'm pretty sure the number is actually higher than that in real life. Breakfast cereal contains different types of marshmallow shapes: 10% stars, 10% crescent moons, 20% rockets, 40% astronauts, and that's actually supposed to say 20% planets. We are interested in examining the proportion of rockets in a random sample of 2,000 marshmallows for the cereal. Sketch the population. So the population is going to be, and this is going to be percentage on my side, and I'm going to do 10, 20, 30, 40. And what happens here is your stars are 10%. So there are my beautiful stars. My crescent moons are also 10%. Rockets, let's do those in red. Astronauts, we got 40% astronauts. And 20% planets. So there's our beautiful distribution. Please label the bottom what's what. Suppose we collect a random sample of 2,000 marshmallow shapes. Sketch a distribution of sample data you would expect to see. How many rockets do you expect to see? So instead of percentage, they're going to want numbers. So what I'm going to do is actually just change everything into, so 2,000, so I could see 10%, which would be 200, 400, 600, 800, and actually everything's going to look pretty similar. There are my stars, my crescent moons. Next is rockets. Astronauts. And then finally planets. And the question is, how many rockets would you expect to see? The expected number of rockets should be 400 rockets. Now suppose we collect many samples of the same size. Sketch the sampling distribution of the proportion of rockets you think you would see. So now what happens is it's just saying, hey, I no longer want the number, I want the proportion. So what happens here is my mean of rockets. My mean of rockets was n times p, which was 2,000 times 0.2. Because I have 20% rockets. So my mean of rockets was 200. But I want the proportion. So my proportion of rockets equals 200 divided by 2,000. And so how many rockets do we expect to see out of that? Oh, I'm sorry, this number is 400. I did the math wrong. It's late at night. So the proportion of rockets we expect to see about 0.2. And then next they ask, hey, what's the standard deviation? Well, from our equation, the standard deviation of proportion of rockets is going to be the square root, and then it is going to be P minus P parentheses 1 minus P, all divided by N. And if you go ahead and plug in, so our proportion is, our probability of getting a rocket is 0.2, so that means 1 minus P is 0.8. How many total do we have? So what you need to do is calculate that, and you get 0.9. I'm going to leave it up to you. You guys need to interpret these two values.